Okay, you're asked to evaluate the derivative of this function using the limit definition of derivative. I call it a difference, which is actually the slope of secant lines joining 2 points on that curve. Here's f of x plus h right here, minus f of x all over h. Question is how to simplify this so that when you substitute 0, you don't get 0 over 0. So I'm going to drag this over here and say I'm going to simplify this complex fraction by multiplying numerator and denominator by the LCD of all these little denominators. So we're turning a complex fraction into a simple fraction. So when I take this LCD times the first term in the numerator, the x plus h minus 2's cancel out, and I get this x plus h times the remaining factor, which is x minus 2. And then when I take that LCD times the second term in the numerator, I get this minus x times the factor that remains, which is x plus h minus 2. And here's the same factors multiplied times the h in the denominator. Now it's simply a matter of simplifying the numerator, which simplifies to this. And you can see the x squareds cancel out. The minus 2x and the plus 2x combine to 0. The plus hx and the minus hx combine to 0. And all we're left with is minus 2h in the numerator. And these h's cancel out. And now when you try direct substitution to evaluate the limit, we're only replacing this h with the 0. And that's the formula for the derivative right there. Now what exactly is that? That's a formula for slopes of tangent lines to the graph at any point x in the domain of the function. I picked 1, for example. When you put 1 into the original function, you get a y value of -1, and the tangent line is using point slope y minus a -1 equals the slope, which I calculated here by putting 1 in for x into this formula. That slope is -2 times x minus 1, the x coordinate of the point that we know about. And you could put that in slope-intercept form. But that's the equation of this blue line, and I needed to find the derivative in order to find the slope of that line. If I go to Desmos, here's the graph that I used for that picture, and you can see that as I move this point around, the slope changes. If I want to get over to the other branch, I got to go like that. And there's some more tangent lines to that curve. Okay, there you go. Hope that helped. If you have any questions, post a comment.